Good morning, good afternoon. Thank you for the opportunity to talk to you again. Some faces are familiar to me here. You've seen me in action before. I'm Justin Murray. I'm a product marketing engineer at Broadcom, and my next 25 minutes or so is to get us into the product. So those who have seen me do this before, please bear with me, fire questions. For anybody who's not seen this before, this will be an introduction at a technical level into the VMware Private AI Foundation with NVIDIA product. Quite a long name, we call it VPFN internally. VMware Private AI Foundation with NVIDIA is a product that's based on VMware Cloud Foundation. You have to have Cloud Foundation to use this product today. So I'll talk a little bit about the architecture at a fairly high level, and then we'll go deeper. My successor speaker, Alex Fanus, is going to get into the journey of adopting this. I'll give you the toolkit. I'll try to bring the tools together so as you can see how they're used, and Alex will complete that story in the next talk. So I will also answer why VCF for private AI, but I'm going to give you an answer from the context of the data scientist. Why would they be pleased with the outcomes that we can offer with Private AI Foundation with NVIDIA? And I'll speak about the deployment options. This is largely a combination of a deep learning VM. A deep learning VM is just a VM that has GPUs attached to it. It could have virtual GPUs attached to it, and virtual GPUs are key to vMotion, which you know about in VMware, is certainly part of DRS, and really is the magic of being able to move a VM from one host to another. We can do that with GPUs. And finally, to complete the story started by my predecessor speaker, Tasha, on utilization and underutilization, how do you see that? What are the tools that enable you to see the GPUs occupied, the GPUs not occupied? We're going to do a huge amount of work on that in upcoming releases. I'm going to show you what's there today in VCF 5.2.1, the currently shipping product in this talk. So the architecture you're possibly familiar with already. At the bottom, you have VMware Cloud Foundation, which is the foundation for everything. 5.2.1 is the currently shipping version at this time in January 2025. On top of that, we layer a blue layer, which is VMware's intellectual property. And some of these names have changed since you saw me talk about this last, and I'll explain that. That really has to do with infrastructure provisioning. It's not data science, it's infrastructure provisioning. The green layer has more to do with data science, or of interest to a data scientist, like, what's my model going to run in? It's going to run in an NVIDIA inference microservice, which runs in a container. So that top green layer, think of it as a set of rather large containers, actually. Containers that run inference servers from NVIDIA, or inference servers like VLLM from Berkeley, where open source inference servers are done. And we want to open this up to you to use other inference servers besides the ones we started out with. So if you were to ask me, what is the progression from last year when you presented this to us first? I would say there are a lot of new things in the set that weren't there at the minimum viable product that we started off with in May 2024. New things like more understanding of model governance. Model governance is a new model appears on the market. I'm interested in using it. What's the safest place to do that? And the safest place to do that in VMware Private AI is in a deep learning VM that's in a safe zone, that's possibly disconnected from the internet. And once I've tested that model and run all kinds of test suites against it to guarantee that it's not harmful, where does it go from there? Part of model governance is promoting that model from a simple, straightforward deep learning VM into a more complex environment that you mentioned, which is Kubernetes. Promoting the model to a level where developers can now use it in Kubernetes. So that's what we mean essentially by model governance.
So when you say in a private place or set apart, I'm hearing almost micro-segmentation language when you speak of governance.
Very much so. Thank you for that prompt. The VMware Cloud Foundation, as people possibly know, is a collection of infrastructure tools and platforms. An important part of that is the vSphere hypervisor that everybody knows and everybody loves. NSX is another part of that, which is our virtualized networking and overlay network on top of the physical network. NSX gives us distributed firewall, which allows us to take one community of users and isolate them from another community of users. And you may ask, what is your story there about sharing GPUs? We can do that. Even with different communities of users, we can share a single physical GPU across those communities. And we can prevent them from seeing each other or interfering with each otother's work as well.
Just as a quick geek, whatever happened to like the OVN, OVS stuff? Did that ever make it into the VCF?
The
OVN, Open vSwitch, Open the whole open source project that was sort of, when you bought Nicira,
yes,
you bought basically Open vSwitch.
Effectively, we productized huge amounts of the Nicira acquisition into NSX.
Right.
Yeah, and then there was the blip. There was the NSX-V.
Yeah,
and there was the NSX- I believe T.
T.
Yeah.
Now you're delving into our history
We've
here.
used the word delve twice now, so
Hey, and we're not AI, right?
We're hip data science people.
Fair enough.
So yes,
governance
NSX T is the currently shipping implementation.
yeah. So if we went into 5.2.1, looked at the manifest as it applies to the NSX component, it would be the NSX-T component.
Right.
Just NSX. I don't have to say dash T.
There is no more V. It's just S. People can't hear you. All right, repeat.
So for those of you listening in at home, I'm on mic. And one of the things was clarified is we need not say NSX dash. We just say NSX now.
NSX.
Okay.
Yeah.
NSX.
Yes. Internally NSX T, but NSX is the product name. Yes.
Do you differentiate model change control?
Model change control is a big subset of model governance, but model testing, model proving,
All done on a deep learning VM in isolation.
all done in a safe place because we don't know what this model is exactly. We don't know how high quality it is. We don't know how big of a GPU it uses, right? What's the latest model on the market today? What kind of GPU does it use? My first question and answer to that is, what is the number of billion of parameters here? That tells me a lot about the size. So there's a whole bunch of data science work to be done here and testing work to be done before anybody uses this model.
Yeah, going back to that same manifest or bill of materials, there'd be like the Ray, environment for Ray for him doing his particular model, and then there'd be maybe the J model where I'm doing a similar but a different change to that model.
I understand all that, but the question now becomes when you create J2 or J3, how does that go through?
Now we have two problems, as they say.
Yeah.
Yeah, there's versions of models to be handled. There's versions of data to be handled. There's versions of the experiment that you're doing.
So how deep are you going in this? How much work is the word governance doing in this chart? I mean, it's a block.
It's a block, but there are going to be a series of things underneath that.
Okay.
For example, and VMs facilitate that because how do I repeat the same experiment over again with different models? I do it in VMs that I've saved off somewhere. How easy is that to do in bare metal? Almost ridiculously hard.
Yeah.
So there are a lot of things that virtualization brings you here to do with reproducibility of the test environment, reproducibility of the tools that you tested with, the data sets that you tested with. You could do very, very interesting version control, as in the question, just using VMs.
When you say VMs, you mean a cluster of like containers and stuff like that, right? Or
Yeah.
All right, just to clarify that.
Think of a VM as a runtime for containers.
Yeah, that's why I wanted to make sure that we were.
Yeah, the virtual infrastructure within the VMware Cloud Foundation.
Where in physical Kubernetes, you're familiar with machines being nodes.
Yeah.
Those nodes are now virtual machines.
That's what I wanted to make.
So when you code
VM, we were talking about a Kubernetes cluster.
We'll provision the Kubernetes cluster later if I get to my demo. When we provision a Kubernetes cluster, it's a set of VMs that are capable of running pods, collections.
Just wanted to be clear. Yeah.
Yeah.
Good. I'm glad.
We haven't seen other acronyms like TKE or other things like that yet, or anything related to like a Tanzu Kubernetes. So
No.
I don't know if we're going to go into that level of detail, but
It's effectively that. It's effectively a workload cluster.
it's included in this VPAF-N.
It's included in VPAF-N and the.
Is it
the
VPAF? Am I saying that correctly? VPAF? Should I not say
VMware,
VPAN?
VMware Private AI Foundation with
So I should
NVIDIA
expand the whole
to be
thing?
totally
Okay.
correct.
Yeah.
But we'll accept that.
The
acronym.
foundation is important because otherwise it's VPAN, right?
Yeah, VMware Private AI Foundation with NVIDIA, infrastructure with NVIDIA.
Okay.
So yes, vector database, our favorite one is Postgres with PG Vector. There was a lot of discussion about vector databases. We are seeing other vector databases out there. We're open to using those.
So just like that similar conversation, the version control, does that extend to things like vector database, or is vector database that would be coming soon where you could do version control related to that?
Vector database is shipping from us today.
Shipping today.
Whether you can version control your data in it, that's a
It's a
feature.
whole nother.
Got it.
And you can plug and play your own RAG or vector solution in there, or it just, I mean, is there ability to put in?
We'll
like a
give you,
vector-
you'll see from me later, a curated RAG design using a vector database.
But I can put in like a MongoDB or.
You can put your own
Okay,
vector
there you go.
database in
Not-
there.
I don't have to go
We're not
exclusively
gonna-
with PG
We're not going to
Vector.
stop you from using.
But it will
your
work in the
tool.
architecture seamlessly.
Yeah,
Okay.
the same architecture, the same attitude to models, new models or different
Okay.
models,
Yeah,
as to every other component.
Okay, good.
Self-service automation is us doing all the work for the data scientist and setting up the Kubernetes cluster with all of the tooling such that the data scientist is ready to go in their Jupyter notebook. Sometimes we call this GPU as a service. We want to remove the infrastructure from the data scientist as a concern. And then GPU management, I'll get into, it's about seeing what the GPUs are doing. And if you can predict what workload you're going to be doing in a month's time, what model you'll be doing in a month's time, we can reserve that GPU for you ahead of time to guarantee that it's there for you. So that's the high level. Getting into a little more of the rationale here. What we see happening among data scientists and AI developers, and they're sometimes the same person, sometimes not, is everybody's in model selection. We have a prime example over the weekend of there's a new model selection to be done now. So this is almost a full-time job for a data scientist. Testing new things. Is this model going to work for us in an orderly way? That's just part of it. Then there's the setup underlying that. What's the infrastructure that this model needs? The question we get at least 2 times a day is, I'm going to do data science, what GPU should I purchase? Well, tell me what model you're going to use, what size it is, and how often a request is going to be made to the application using this, as you saw in the charts. So setup, RAG, I'm glad you mentioned it, retrieval augmented generation, which you can think of simply as the combination of a database plus a model to get you a truthful answer. So the database has a source of truth. It's supplying some of the answers to the model. The model is massaging those answers into readable text. And finally, we have the application that you have to build on all this. So this is happening across the data science community, but it's not happening as a single thing. It's happening on multiple models, firstly, on multiple data sets, in multiple departments with different people doing it. The answer here is VMware Cloud Foundation and VMware Private AI Foundation with NVIDIA, where all of these people are operating in their isolated deep learning VMs, their isolated Kubernetes clusters. They're operating independently of each other. Otherwise, this is going to be a management nightmare, right? So what we're doing, if you gave me a word for it, is management of the infrastructure underneath AI. Management is important here.
And this reminds me a lot of what VMware was doing for conventional data center resources back in the day, aggregating them, managing them, assigning them to specific tasks as needed. It's just a lot more frequent and a lot more flexible with AI applications because it's a shorter term commitment, shorter term use case.
Absolutely.
But it's still all about that fundamental question of optimizing the use of resources.
Yes. How much can these people share that are doing different work in different machines? How much can they share a GPU? How much can they share the storage? We can provide answers to this.
And is there a self-service story that's differentiated now? So to the earlier point Stephen made, VMware is very familiar to the IT realm, but getting a developer or a scientist, type interface or interact with a VMware product, probably a different conversation.
Absolutely, we want to do that. And that's the setup phase and the RAG phase. I'm going to deploy enough Kubernetes to run RAG in my demo at the end here. And I'm not going to ask a data scientist any other question other than, how much GPU power would you like? That's essentially the conversation. Tell me what GPU power. They're going to say 4 GPUs and maybe use 1, but I can provision a certain range of GPUs for them automatically.
And so the service catalog is consistent with what's available, and you can do your chargebacks if you need. I think we talked about that earlier. So
right. So this is what used to be called VRA, vRealize Automation. We call it VCF automation. It has the capability of imposing charges on people.
Just a note: infrastructure is 90% of the challenge, not half the challenge.
Thank you. So the left-hand side is infrastructure. The right-hand side is data science. We want to take care of the left-hand side and also supply the tooling that NVIDIA gives us. And actually, we're building some of our own. We want to supply the tooling that the data scientist likes on the right-hand side. So the data scientist says, I need a Jupyter notebook with Llama 3, 7 billion, and I think I need 1 GPU for that, but give me the appropriate amount of GPU, Mr. DevOps person, Mr. IT person. Within 15 minutes, they have what they want. That's the idea. So cloud-like, but really on premises. So you can deploy one of these manually. A deep learning VM, as I said, is a regular VM with a GPU attached to it, or a part of a GPU attached to it. A part of a GPU we refer to as a virtual GPU, a vGPU. For those who are familiar with VMware's past, a virtual CPU allowed many people to share the same CPU. A virtual GPU does exactly that as well. So that's what differentiates a deep learning VM from any other. And we put some tooling in there as well, Conda, PyTorch, Jupyter Notebook. We put that in there automatically for you. So deep learning VMs are the starting point in modern model governance. Kubernetes is the sort of endpoint, and the thing that links the two together is Harbor, the repository for models.
I'm sorry, but Red Hat is doing some really interesting stuff with InstructLab for helping you sort of create abstractions for PyTorch, so you don't have to be sort of an ML genius. Are you doing anything like that? You're including PyTorch, but that's an interesting narrative going on where they're sort of trying to help it make it easy to do training for the non-AI expert. Is there anything going on like that?
Yeah, when you get a deep learning from us, and at boot time, everything is placed in there. Conda is placed in there, which is an internal virtualization environment within the VM itself. So there are 2 layers of virtualization happening. There's the VM level, and then there's the Conda level, and those 2 are completely compatible with each other. There isn't.
Yeah, I was just going about like I don't know if you've seen InstructLab.
I haven't.
You should look, because they're taking another step where they're literally making PyTorch and training commoditized, where you don't have to build, all the details of backpropagation.
Interesting. I will look into that afterwards. Yeah, thank you for pointing that out.
I think you alluded earlier to vMotion. You have that too, that you use the vGPU, where you could move workload from one to another one.
Absolutely. And that is going like a rocket ship in releases that we're coming up with soon. I've seen vMotion of a 48 gigabyte GPU attached to a VM in about a second or 2.
And can you use that for snapshotting?
You can certainly snapshot a vGPU aware VM, yes. Yes. So our intention 4 or 5 years ago when I started working on GPUs was everything that you can do in regular VMware, you can do to GPUs. Snapshots, vMotion, DRS, everything. So that's a powerful story for a data center that runs on VCF today, or even vSphere moving to VCF. So we provision these manual deep learning VMs for you. You don't need to clone them from anything. We'll clone it for you. We'll put the tools in there. And later on, when you want a Kubernetes cluster, we'll create that from templates and clones and put all the tooling into it that you would need. What that looks like, and typically you'll do DLVM for prototyping, for testing, Kubernetes for production or pre-production staging. So in VCF, there are 2 categories of things. There's a management domain and a workload domain. I'm just going to make one remark here. We'd like you to start off a clean AI environment with your own workload domain that isolates you from other people being managed by the same VCF instance. So that's all that's being said here. And on the right-hand side now, you're going to see a slide version of the provisioning tool. which is I've decided to deploy a deep learning VM. I'm going to put it in a namespace of its own. This was referred to previously as a resource boundary, a place where we can isolate certain people from other people. And I can do that with my Kubernetes cluster as well, and they can coexist. There's no difference to us between the VMs that run a deep learning VM and the VMs that run a Kubernetes cluster. They're both regular VMs. Some happen to have GPUs assigned to them.
Who cleans up namespaces? Is that you're also responsible for consolidating namespaces, curating that?
Yes, anything that's new.
When you said the VM, like I think VM sprawl, I would also think maybe namespace sprawl.
Yeah, namespace is like a resource pool in traditional vSphere. It's a resource pool plus, but it's got all kinds of access in it. But so we do look after namespaces. We create them in the first place. We destroy them when you destroy one of these deployments, as we call them here. A deployment can be a full-blown Kubernetes cluster with many VMs in it. Some workers in that cluster have vGPUs. Some don't. They could even have pass-through GPUs if you were really extreme about it. And they can have multiple GPUs assigned to one thing if you really need it, or shares in a GPU.
That looks like a small TKG there that you've got in the black.
Yeah, I shouldn't be using that acronym. I should be using VKS, VMware Kubernetes Service, but it's exactly the same idea. Yeah, thank you for pointing that out. And we're not just stopped there. We're also provisioning data services and provisioning Harbor as a repository for both containers and a repository for models. So all of this is installed for you at the VMware Private AI Foundation installation time.
And so that feels like when you did your Bitnami acquisition that became the catalog of all the things that you could kind of load as VMs, on demand of particular flavors of open source. So, okay.
There is a catalog here too. It's a VCF automation catalog. And these things that you're seeing on the left-hand side, the AI workstation, the Kubernetes cluster, are catalog items within that catalog. But the great catalog in the sky is Harbor to hold all of the containers, and that's particularly useful for offline systems, air-gapped systems, and we'll put models in there as well. We have OCI ways of doing models now. So the workstation I showed you last time, I won't demo that again. A VM comes up, it's got some base things in the image, Conda and PyTorch, and then we insert into it a bunch of containers from NVIDIA GPU Cloud. Now we can get containers from elsewhere. We can get them from local copies on Harbor. It doesn't have to be NGC-based containers. It could be others. But the starting point last year was NVIDIA GPU Cloud authenticated containers tested by NVIDIA and tested by us. Containers like the NIM to run a model, and we'll mount a model into that NIM. A retriever, which accesses data in a vector database and presents it to the completion model at the end of RAG.
I don't want Conda and PyTorch in my deployable. So is there a difference between the two different structures? Like in other words, you talked about...
You can customize this image that we give you to take out things if you don't like them.
Okay, but you have to do that. So you get the base image. So if you just deploy it by default, you're going to get Conda in a deployable image, which is not a really good thing to
there's
do.
no reason you can't take our image out of the content library that you've put it into, instantiate it,
I think customers wind up doing that, and then you'll have all these security
we like that. We'd like customers to customize it for their own needs.
And in your classic VCF days, you had the kind of the duality was you had the virtual infrastructure on one side and you had your VDI kind of experience on another side. Is that a similar motif here with the AI workstation? The primary benefactor of that, the user, the use case is this data analyst. They want to get something done. To your point, like whatever their magic menu is for their project, there is the customization, much in the same way there was golden images or image management with VDI. So we're just kind of taking that same approach and personalizing it to this kind of new customer internal to IT.
There's a great analogy there. I hadn't thought of that before.
Okay.
Thank you.
It wasn't ever just VDI. It was just basically a catalog of any VMs that you possibly want. VDIs were the ones that you would typically mass deploy, but it was always just a library.
I was thinking more in terms of the personas of those VDI images, like you're a knowledge worker versus I'm a data worker versus et cetera.
And interestingly, the whole vGPU movement started in VDI because being able to share GPUs, it started there, but we've moved on from there. This is talking about types of GPUs that now don't do graphical work anymore. They're pure compute oriented.
So John, these were always just things that you custom add to your library, and you can pull them out as you.
Yeah, I get that. I just, customers will tend to deploy this is DevOps 101, right? Like people will build and not customize it for deployment, and then therein starts all the vulnerability opportunities.
Sharing GPUs happen. I think this is a key.
Okay.
Yeah,
aspect of what we're doing.
that's the secret.
So
right now.
this is a big topic. I'll give you 2 minutes on it. The question I was asked here was, tell me how this GPU sharing happens. This is a feature of 2 NVIDIA drivers, a host level driver and a guest level driver that we install for you. They're installed into the host by our lifecycle management tooling. They're installed into the guest OS of a VM using our own automation tools. What they present to you is the capability to say for any one VM, how much of a share of a physical GPU do I need? Let's say you need half of a GPU. That would be called a virtual GPU profile, and that's identified in the NVIDIA driver, and you assign that to your VM. You say, I'm going to take this virtual GPU profile representing half of a physical H100 and assign it to my VM. There are a bunch of decisions that you can make about tuning that. Should it be time sharing with other sharers of that GPU, or should it be completely isolated from the other sharers of the GPU? And
You say completely isolated, so you could have like 3 workloads running on a physical GPU, but they're physically, or at least virtually separate in that environment, rather than trying to time slice.
If you choose an option for virtual GPU called MIG, they are physically separated on the GPU. They're getting different slices of the compute.
So a quick question: Does this Private AI Foundation include the bit fusion technology?
It does not. We've sunsetted that technology.
Okay. Do you have any way of sharing vCPUs across the network?
There are technologies around that could do that, but today our sharing technology means the VM that's using the GPU is on the same host as the GPU itself.
Okay.
Yeah.
Okay.
We decided for various reasons not to continue with that remoting. Okay, so we were talking about virtual GPUs and Kubernetes. The way in which it works is those 2 drivers, and you choose whether you're going to use time sliced or MIG, and then you choose your sizing, and all of that is done through a user interface called Virtual GPU Profile Setup. Once that's set up, and let's say you chose MIG, you and I are completely isolated from each other on the GPU hardware. We're isolated from each other in separate VMs. We don't see each other. We don't know each other exists. Time slice is a bit more lenient than that. We could have a noisy neighbor problem, but MIG is common in inference workloads. Okay, so that was a quick introduction there. So we're going to load up your Kubernetes cluster with the appropriate containers that you identify. You identify those by telling us what package you want in your NVIDIA, from your NVIDIA set. And to do that, you need an NVIDIA license, and you purchase that from NVIDIA as part of their NVIDIA AI Enterprise, the green layer of the suite. Okay. Data Services Manager is a tool that comes as part of our portfolio for provisioning databases in general, but here it provisions vector databases. It provisions Postgres with PG Vector on it as our first step into vector databases. Last topic. There was a lot of talk earlier about GPUs and their utilization. How do I see it?
Can I ask one question?
Yeah, go ahead.
So with all of these different packages, how are they kept up to date? Like if an update is released, is that on the users to do, or is there a push down from the platform to do it?
Yeah. There is version control across 2 different infrastructures here. There's version control of the NIM layer. NVIDIA takes responsibility for that. And you control what version you're using because you're downloading those containers into a Harbor repository. We'll allow you to patch, as we always have, vSphere, VCF, all of the tools that we'll supply. We'll keep those up to date if you do auto life cycling with us. So there is a bit of a combination going on there between the components that you're using from NVIDIA and the components that you're using from us.
And so your Postgres PG vector implementation is a container that's in Harbor. And as long as you manage Harbor,
it can be containerized. You can also run it just in a straight VM as a set of processes in the VM.
Okay. All right.
Yeah. So there are at least two flavors of it today, but I've seen it run as a regular container.
Yeah, it would make more sense, but yeah.
So this is a sort of beautiful picture of the console that you see in VCF operations, telling you the temperature of each VM. And if the temperature is bad, we're going to put it up as red, telling you the core consumption on the GPU and telling you the memory consumption on the GPU. Memory consumption is probably going to be the most important because that's the premium with these large language models.
But not power.
We're going to show power as well. We have that in plan. Now, what this doesn't tell you is which virtual GPUs are occupying the physical GPUs. And that's coming in the vCenter user interface as well. So we're doing a lot in this space to give you more and more detail about what your GPUs are doing.
And that's vCenter. I can't see on the front. So that's
this is VCF operations.
okay.
But there will be also screens like this in the vSphere UI.
So does that excuse me? Does that mean now we're back to multiple consoles depending on who you are and what you're looking at? And
not every user is confident or allowed to use the vCenter UI. So this is for this specialist DevOps person whose job is to look after the data scientist and make sure they're happy. But yes, you could be using the vSphere UI, the client, and VROps together, and they will feed each other data so that you don't have to go to
right. But so it's still two separate products. It's not one product with different windows depending on your role or your responsibility.
You're right. Now
Okay.
they are going to exchange data. So what you could see in one, you can see in the other. But if you want to, you can use two consoles. Yeah.
So those basic blocks and any of those, are those VMs that are using those GPUs? Is that how I read that?
The green blocks are actually GPU representations of GPUs.
Separate GPUs. I see.
So on that left-hand side, there are two GPUs on the host, and the host is represented as the enclosing panel around the green blocks or the red blocks. Now we're going to make this a lot prettier. This is the first view of it.
I guess my question was, and maybe you answered it already. Do you know what VMs are actually using those GPUs?
I do, because I can see the full topology in the pane immediately beneath the colorful pane here. You can see which host it's on, which VM it's on, which cluster it's in, and which VC is managing it. You'll see the entire topology.
Data being saved so that I could later, for example, do a time series analysis on it?
Yes, this data is in a database that's accessible programmatically such that you could do your own analysis on this. Yes, there's a repository behind this. So I'll stop here.
So it's the persona this is for from a ops perspective, like a platform engineer?
Yes, there are many names for this person: platform engineer, DevOps engineer, Kubernetes manager, data engineer who's serving the data scientist, any of these titles, or the traditional IT admin that we've always helped. So a chatbot, an NVIDIA chatbot, you get this for free with the package. This is not a production chatbot. This is a very simple one. We submit a question to it, and it gives us various hyperparameters like temperature, the amount of randomness the model is expressing. And it says, I apologize, I can't give the answer to your question. So the benefit of RAG is I can attach a database to this and switch that database on. The database here contains some data that I've previously loaded up. And I'm going to ask the same question again, but this time with the vector database active behind the scenes. And how does the question look here? Well, the answer is very directed, very precise, because the model has been fed with data from the vector database that is the source of truth. This is a very tiny example, but this exhibits why RAG is a good idea, why RAG is the starting application that many people are choosing here. So what's behind the scenes of that? We provisioned an AI Kubernetes clusters. This is the catalog that the gentleman here asked about. We can have any variety of catalog item that we choose to. This is customizable. We're going to provision a Kubernetes cluster here. We're going to be asked, what's the name of that Kubernetes cluster? What's the GPU power? That's the key question. What's your license for using this GPU? Which we fill in the blanks here. Here's my license. Hit submit. And about 5 to 10 minutes later, depending on how fast your system is, a Kubernetes cluster is available to the end user that's running that application that we just saw, that RAG application that we just saw. So I'll speed through this here. Okay. Something like 55 steps were taken in the background to provision that. So a lot of work going on that you don't have to worry about anymore. Those are all the steps.
Is that customizable? Like, is that sort of Terraform? Or?
Yes, it has a scripting mechanism that you see on the right panel here. Sorry, you didn't see it, but there is a whole scripting language behind this that, like Terraform, like Ansible, that you can configure for yourself. The end result here is a URL that you see under the application here. If I were to click that URL, I would see exactly the application that I used at the beginning of this. So what we saw here is VMware Private AI Foundation with NVIDIA, deep learning VMs, Kubernetes clusters, virtual GPUs for sharing, and management tools for seeing the utilization of your GPUs.
Maturity question. Enterprise IT administrators, the data analysts, you're within the enterprise. What if you're a service provider, a managed service provider, a cloud service provider within like the larger VMware community? Any of this fit for that purpose, or is that coming soon to a theater near you?
It's in progress. We have cloud service providers, as we term them, very interested in providing AI as a service to their clients.
Exactly. Yeah.
People who serve the government, for example, people who are, by definition, making their money out of cloud providing. They're very interested in using this, and some are testing it right now.
Roger that.